Welcome back. Now we're going to do, again, take some stuff we've already done and already know how to do and put some things together to try something new. And this is a very important lesson because not only are we going to take what we already know about ratio tables and equations, but we're also going to kind of drive this into a new field for us, sort of, and that's graphing equations, okay? We spent a whole unit on getting to know the coordinate graph. This time we're really going to put it to use with problem solving, okay? I have an equation kind of above my head right here. Can you see that? Any guesses what it might mean? It reads that h equals 3 times p, okay? There's a big hint right there too. I really do, I really like hot dogs. They're not even that good for me, they're just so good. This equation actually matches something we did way back when we were talking about ratios in the first unit. Remember we did ratio tables? And I had mentioned that I want to have a party and I want friends to come. And I'm assuming that all of my friends probably want 3 hot dogs each. So I had to figure out, based on how many people show up, how many hot dogs am I going to have to buy? And I made a T-chart, I made a ratio table, and I kind of just randomly chose numbers of people and how many hot dogs I would have to buy if those people showed up, okay? And then I also went backwards and I said, if I buy 90 hot dogs, how many people do I hope show up? Remember that? So what I did with that was, and I did the equation for you, you're welcome. I basically said, how many hot dogs do I have to buy if I give 3 hot dogs per person, and P stands for how many people, okay? So if I also use the independent-dependent variable thing, I can say that the number of hot dogs that I buy depends on how many people show up, okay? I can't control how many people show up. I can drive around the neighborhood and say, yeah, get in the car, let's go, we're going to my party. And people would think I was kind of weird and probably wouldn't want to be my friend anymore after that. So the only thing that I can really decide is how do I choose how many people are gonna, how do I choose the number that I'm gonna use to decide how many hot dogs, okay? I can't really choose how many hot dogs to buy until I know who shows up. Yes, I can't control who shows up, but I can control what number I put in here to figure this out. Okay, so this is the dependent variable, this is the independent variable. And I think it's most clear when you ask which depends on which. And obviously, hot dogs that I buy depends on how many people show up, right? So this is the equation for that situation. Now let's make a table. Excuse me, allergies are bad. Anyway, let's make a table for this, and it's gonna be a little bit different. I'm not gonna make just one T-chart. I'm actually gonna make a double T-chart. Watch. Here's 2 lines with a line across the top. See how that looks like 2 T's? So it's like a double T-chart, okay? Because I have a column for 3 different things. First column, I'm gonna put the independent variable. That's the number of people in this column, okay? In this column, I'm gonna write the whole formula. I'm gonna write the whole equation. I'll show you why in a bit. And then in this one, I'm gonna put the dependent variable. Because this is what I'm trying to find out. Based on what happens here and here, this will tell me how many hot dogs to buy, okay? Now, I picked up a bunch of random numbers in the ratio tables lesson. I don't remember how many I did. I think I did 1 person. I did 5 people. I did 10 people, 30 people. But I'm not gonna be random anymore. This is important, guys. We're not gonna be random with how we list the numbers for the independent variable anymore. And the reason for that comes in the next lesson. I could just say because I said so, but actually the reason comes in the next lesson when we start putting these on a graph, because we're gonna wanna use these numbers to scale our graph, to actually show a nice systematic way of looking at this. So what I wanna do is I wanna think, how am I going to write numbers, how am I gonna make a list of numbers here that makes sense? And if I'm talking about people showing up, I could go ahead and count by ones, 1, 2, 3, 4, but that limits me. That says, okay, so I'm only expecting 5 people to come to my party? I hope not, okay? I could go by 2s, and if I decided to make a list of 5 items, that would be 2, 4, 6, 8, 10. That's a little better. But what if I'm expecting a lot of people to come? I'm gonna count by fives for this one, okay? Just so I can get a pretty good picture. Here's 5, here's 10, here's 15, here's 20, and 25. So here's the independent variable, the number of people. Notice that I get to choose what these numbers are. I get to choose what the scale is, okay? I don't get to choose this answer because this answer depends on this list. Now, what is this middle one for? Basically, this is where I show what I'm doing. And the only thing I'm really doing in this middle column is I'm taking this value of p and I'm replacing the variable each time. Watch. I'm going to rewrite h equals 3, but instead of writing p, I'm going to open this up. Okay? And I'm going to put the value of p in there. Why? Because it shows very clearly hot dogs on this side, my dependent variable here all by itself, and calculations happening here. Okay? I don't have to show all of my work here. I just want to show what's happening now that I've put this value here. Okay? And it should be easy to see. 3 times 5 is 15. Okay? So this first row basically reads, if 5 people show up, I need to buy 15 hot dogs. All right? Next one. Again, rewrite that equation, but open up the variable for the independent variable and put in the value, and then do the calculation. 3 times 10, 30. Now we'll put in this one. 3 times 15, 45. Next one. 3 times 20 is 60. And then the last one, I'll write it again and plug in 25. 3 times 25 is 75. Okay? This gives me a nice list of possibilities, all right? There is no one right answer for either of these variables. So it's up to me to come up with a value or a list of values for the independent variable so that it will spit out values for the dependent variable, all right? There are 2 names for this, 2 names for this thing happening here. And I wanna make sure you have them in your journal so that you can kind of associate these two. So if I ever say, hey, use this to find values for this. The first thing that you can call this table is a table of values. Makes sense, right? This is a table of values for the independent and the dependent variable. So that's one name for this. There's another thing you might see, especially later on in pre-algebra and in algebra. This is also called an input-output table. Why? Well, because you have this equation right here, and you get to choose the input. Input means this is the value you're putting into that equation, and once you do the calculations, it outputs the dependent variable, okay? I always said, I think of this as like a little machine. You put in one thing, you put in the raw material, it chews it up and calculates it and processes it and spits out the output, okay? These two are names you will very often see for this table, all right? Sometimes they might just call it a table, but usually you'll see one of these two. And always from me, you'll see one of these two, unless it's obvious that I want you to set up a table of values, okay? So there's this. I'm gonna leave it for just a second while you make sure you copy it. And then I'm gonna show you one where we don't have any problem solving to do, we just have an equation, all right? Now keep in mind, we're not done with the hot dog scenario. we're gonna graph this in the next lesson. So if this is in your journal, that would help you out because it's all right here for you, all right? And I'll go ahead and rewrite the whole table again, don't worry. So let's try one more example, but this time I'm not gonna use a story. we just did to make sure that we understand how that works, okay? Let's do y equals, we don't know that, 5x plus 1. If I were to ask you the previous equation about hot dogs, what kind of equation is that? You would say it's a one-step equation, and that's because there was only one operation in there, right? We only had to do one type of calculation, and that was multiplication. We took our independent variable, multiplied it by 3 every time, and that gave us the dependent. So that was a one-step. This one has multiplication and addition. This is a two-step equation that we're going to solve using a table of values, okay? The reason we have to solve this using a table of values is because it doesn't have one right answer like we were dealing with previous, okay? Remember when we had our mystery number and 5 times the mystery number plus 1 gave us one specific number? Then there was only one value for x. But now that we don't know what that is, there can be infinitely many solutions, infinitely many answers for that and that. The only thing we have to make sure is that the relationship between y and this whole side right here stays true, okay? If we put in a value for x and calculate it and it spits out a value of y that is not the same and it's off balance, then we have to check our work and try again. Remember that it's all about the balance. So I'm gonna go ahead and make my double t-chart. Okay? And you're always gonna start with the independent variable, okay? Now remember, when you look at an equation like this, basically what it's saying is that the value of y depends on what happens over here. This is all being calculated and things are interacting with each other. Y is just kind of sitting here waiting, okay? It's saying, okay guys, whenever you figure it out, my value depends on what happens over here. So we're always going to start with the independent variable. And we're always going to end with the dependent variable. And then in the middle right here, like I said before, go ahead and just copy that equation here, so that when we go down our list, we know that basically we're just taking the value of the independent variable, plugging it in where x should be, and then spitting out a value for y, okay? When you start getting good at this, when it starts, when you start realizing, oh, I really don't need this middle column, you could take it out. But honestly, I've been through very, very many levels of math, and when I set up a table of values for an equation, I still use this middle column, okay? It's helpful, why not? So, on the first thing that we did with the hot dogs, we were only dealing with positive situations, okay? I wasn't gonna say, okay, 5 friends are coming, so I'm going to, so each person gets -3 hot dogs. Or I'm not gonna have 3 hot dogs for every -2 people. That doesn't make any sense, because then I end up people coming to my party and owing me hot dogs, or I have negative people showing up. That's not realistic. That doesn't fit real life, okay? But there are situations where negative numbers can come into play, and we'll get into some of those a little bit later. But for now, when you see an equation like this, you don't just have to pick positive numbers for x. And in fact, in the next lesson, when we start graphing these, I'm gonna take this equation and I'm gonna put it on the full coordinate spectrum, the full coordinate grid, okay? Where x and y cross, and there's negatives and positives, kind of like we saw when we were working with the coordinate graph. The hot dogs problem, we're only gonna use quadrant 1, positives. But this one, we're gonna use all 4 quadrants. So here's how we can do that. We want this to stay simple for us, but we need at least how many points to make a line? We need at least 2, and you should always have 3. But for this, I think I'm gonna go ahead and put 5 values for x, okay? And I'm gonna start at -2 and go to +2. That gives me 5 values that are nice and simple, and I can see where everything crosses everything else. So I'm gonna do -2, -1, 0, 1, and 2. Notice I listed them in order from least to greatest, okay? You don't have to, but it keeps everything very well organized. Now we have a list of independent values. We're going to put them into the equation. Start with -2. So we'll rewrite the equation, but open up that x, right? And plug that value of x in there. Okay? Now if you have a workspace off to the side, that might help with a two-step equation. I'm going to go ahead and mentally go through this stuff, but don't be afraid to take this and rewrite it here and then follow order of operations. Which tells me, by the way, to do multiplication first, right? So 5 times 2 is 10. A positive times a negative is a negative, so that's -10 so far. But I have to add 1 also. A -10 plus a +1 means subtract absolute values. 10 minus 1 is 9, and keep the value of the higher absolute value. So we have a -9 that spits out of this input-output machine, okay? Next one. Y equals 5 times -1 plus 1. I just put that value of x in where x used to be. The rest of it stays the same. Again, order of operations tells me to multiply first. So 5 times 1, and it's a -5, right? And then -5 plus 1, -4. Now 0. Now this part should actually be a little bit easier because y equals 5 times, plug in the 0, plus 1. 5 times 0 is 0, right? So the only thing we're left with is that 1. If I plug in a value of 1, five times 1 is itself, it's 5. 5 plus 1 is 6. And then finally 2. My independent value of 2, clean that up, that looked messy. My independent value of 2 goes in here. Everything else is the same. So 5 times 2 is 10 plus 1 is 11. And that's my table of values. That's cool, but what do I do with this? That's the next lesson. We have a nice list of independent variables and their dependent results, okay? This is a completed table, but we're not done with it. And we're not done with the hot dog one either. But I'm gonna stop for now because I want you to practice. In the first sheet that you see underneath this, the first exercise set, it's basically, I think it's 2 equations that I want you to put into a table of values. Now, my table of values for the exercises only has an X and a Y column. If you want to rewrite that in your journal so that you can put this middle column in there, that might be a good idea, okay? And then the second one, the second set of exercises underneath that is problem solving. Now, I am giving you a word problem, and it would be a good idea before you actually, well, I don't know if you can really do it. It would be nice if you could visualize how the equation looks, but I give you the equation, okay? Just like I did with the hot dogs and the people up here, I gave you the equation. All you have to do is decide which one's independent to put on this side and which one is dependent to put on this side, okay? So, good luck with that. Meet me back on the bottom video and we'll go over those together, okay?